All right, in this video, we are going to be doing some example problems related to rotation. Rotation is one of the three types of rigid transformation. It is largely considered to be the hardest to perform of the three, especially without mucking up the visuals. I'm going to try my best to visually explain how to do rotations without creating too much of a mess of the graph. So bear with me. So our first problem says rotate triangle ABC 90 degrees around point A. So first thing we need to establish is a center of rotation. Just as with the reflections, we need to establish a line of rotation. We can't have a reflection without a line of reflection. You can't have a rotation without a center of rotation. The problem establishes it as point A. Point A in this case is one of the 3 points of the triangle. So if we're rotating around point A, lucky us, A is not going to go anywhere. We don't have to worry about it. Instead, we just have to worry about rotating B and C around point A. Only 2 points, piece of cake. So the first thing that we're going to do in order to get a good sense of the rotation is to set ourselves up with cardinal directions from the center of rotation. So not to muck things up too much visually, but I am going to do dotted lines indicating the cardinal directions from A. So we've got straight up, straight down, straight to the right, and straight to the left. And we know that a 90 degrees clockwise rotation is going to be rotating this way. Remember, if you're imagining a clock, here's 12 o'clock, here's 3 o'clock. If we're rotating 90 degrees clockwise, 12 o'clock is going to become 3 o'clock. 3 o'clock is going to become 6 o'clock. 6 o'clock is going to become 9 o'clock. And 9 o'clock is going to become 12 o'clock. Now, once we have our cardinal directions established, we are going to make comparisons between our points that need to be rotated and those cardinal directions. And lucky us, one of our points is already on the cardinal direction. C is directly to the right of A, which makes rotating it really, really easy. Since it is directly to the right, when we rotate 90 degrees, it's going to be directly underneath A now. So it's 1, 2, 3, 4, 5 units to the right, and that is going to rotate to become 1, 2, 3, 4, 5 units down, and here is C prime, 5 units underneath A. So I'll even draw the line there since we know that they're going to be connected like that. All right, so all that's left is to find B. B, unfortunately, is not directly on a cardinal line, but it is pretty close. It's mostly up, which means that since it's mostly above A, its rotated version is going to be mostly to the right of A. So we could start with that. We could say that it's mostly 1, 2, 3, 4, 5, 6 units above A, and therefore it's going to turn into 6 units to the right of A. So we'll go 1, 2, 3, 4, 5, 6. Then from there we just make the little adjustment. It's 6 units up, and then it's also 1 unit to the right, which means that since right is turning into down, then we just dip ourselves down 1 unit from there, and we end up with B prime. So when we connect the dots, we've got our rotated triangle. B was 6 up and 1 to the right. that turned into 6 to the right and 1 down when it rotated. C was 5 directly to the right. It turned into 5 directly underneath. Next one. Rotate triangle ABC 180 degrees around point B. So our center of rotation, once again, is a piece of the triangle. This time it is point B. So once again, we'll start by making our cardinal directions from point B, our center of rotation, so that we can make comparisons. Now, since we're rotating 180 degrees instead of 90, that means that we are going to be going all the way around. So up is going to turn into down, down is going to turn into up, left is going to turn into right, right is going to turn into left. We're going to end up with the exact opposite directions. So we already know that given that idea, well, C is roughly beneath B, which means that its opposite is going to be roughly above B. So let's get into the exact specifics of it. So we can see that to get from B to C is 1, 2, 3, 4, 5 down. So 5 down and 1 to the right. That's a 1. And so that means that we are going to be reversing both of these, making them the exact opposite. So 1, 2, 3, 4, 5 up, and 1 to the left this time is going to get us C prime over here. And then as for A is more or less to the left and a little bit down. So we could see how far left. It's 1, 2, 3, 4 to the left. So it's 4 to the left, and then 1, 2 down. That's how we get to the original. So we're going to do the exact opposite. We're going to go 4 to the right. 1, 2, 3, 4 to the right. And instead of 2 down, we're going to go 2 up. 1, 2. And we end up with A prime right here. So there's our new triangle right there. Number 3. Rotate triangle ABC 180 degrees around point D. So in this case, our center of rotation is an external point. It's not part of the shape, which means we will have to rotate all 3 of our points around it. Once again, it is 180 degrees, so we're looking for exact opposite directions. So we know that the triangle in general is to the left of D, which means that our rotated version in general is going to be over to the right of D at a similar distance. Well, at the same distance. So we take each of our points one at a time. C is 1, 2, 3, 4, 5, 6 to the right. Sorry, left, and 1 up. Which means that we can go opposite. It's 1, 2, 3, 4, 5, 6 to the right and 1 down. And that's where we end up with C prime. B over here is 1, 2, 3 to the right. Sorry, 3 to the left and 1, 2, 3 down. Which means that we're going to go the opposite way. 1, 2, 3 to the right and 1, 2, 3 up. There's B prime. And finally, A is 1, 2, 3, 4, 5, 6, 7 to the right. And 1, 2, 3 down. So we'll go, I keep saying right instead of left. So we'll go 1, 2, 3, 4, 5, 6, 7 to the right. And 1, 2, 3 up, and we end up with A prime. And there we have it. All right, last one. Rotate triangle ABC 90 degrees counterclockwise around the origin. So the origin is 0, 0, which is right here, which means that our cardinal directions are already drawn for us. They are our axes. The x and y axes serve as our cardinal directions. Since we're going counterclockwise, we know we're going this way. We also know that since the triangle is kind of around the origin, that means that it's going to remain around the origin. It's not going to fly off into one of these random corners. It's going to mostly overlap its original position. So now we'll get started on the individual points. From the origin, we can see that, I forgot to label them. I will label them. A, B, and C. We see that A is 1, 2 to the left and 1 down. And since we're rotating that, our left becomes down. So we turn from 2 to the left into 2 down, and 1 down turns into 1 to the right. And we put our A prime right there. So just to illustrate a little bit better, we've got that L shape there. It rotates, and now our L shape is down here. Okay? For C, we have 1, 2, 3 up, and 1 to the right. Up is going to turn into right, so we'll have 1, 2, 3 to the right, and 1 up, and that gets us C prime. And then finally for B, we've got 1, 2, 3 to the right, left, right, and 1, 2, 3 down, and that's going to turn into 1, 1, 2, 3 up, and 1, 2, 3 to the right, and get B prime. So as predicted, we've got a triangle that overlaps with the original once it has been rotated.